Hi everybody, hope you're doing well. If you're watching this video, this means that we are starting week 3 of the 4th marking period and week 3 of what you're learning here in Algebra 2. We're already at the midway point of Unit 8, as today we're going to look at Section 5, which deals with how to graph logarithmic functions. In the last section, we introduced what a logarithmic function is, and that's what we're going to spend a good chunk of what's left in this chapter exploring. We will circle back to exponential functions as all of these things kind of relate to one another, but you're going to see that word logarithm for the next several lessons. You can see I've got the split screen up with the graphing calculator. Obviously, we're graphing stuff. As we're going through this, it would be helpful if you have your graphing calculator with you or something that will simulate what a graphing calculator will do. So, this lesson should be a little bit shorter than some of the other videos because there's not really a whole lot here. You guys have graphed 100 billion times. I just want to make sure that you're punching things into the calculator correctly and getting the answers you're supposed to. Graphing logarithmic functions, we talked about in the last lesson how a logarithm is the inverse of an exponential function. Beginning of the chapter, we graphed exponential functions, so you can kind of see on the screen here in the dotted lines up at the top how basic exponential functions are graphed. So when you have a base that's greater than 1, you can see how in the dotted line of the first example, it goes left to right upward. If you have a base that's between 0 and 1, it goes from left to right in a downward direction. Basically what happens is the logarithmic form of these functions basically reflect over different lines. I don't need you so much to memorize that, but if you're wondering why I have all these different drawings here, basically in the first example here, the long and short of it is if I have an exponential function with a base greater than 1, if I were to mess that around and turn that into a logarithm, it makes this really nice reflection over this diagonal line. Basically, it goes upward from left to right, but from an opposite direction in comparison to the exponential. With the second graph, where it's looking at a base between 0 and 1, it's not quite the same. They do cross pretty nicely, though, over this diagonal line that's magically in the middle of the graph here. But it kind of goes the same direction, but it just kind of has a less sharp of a curve when you graph it. Honestly, not a gigantic deal there. If you're wondering why, though, those two graphs are kind of paired with each other. Mainly, it's, again, they are inverses of each other, so there is a relationship between the logarithm and the exponent. Great. Awesome backstory there. Let's take a look, more importantly, at how do we actually graph these. So, 3 quick examples here. This is also to make sure that, again, you can punch in logarithms correctly, so this will tie back to what we did in section 8.4. So, let's talk about how to graph 1a here. Y equals log base 3 of x. So, unless you have just log, so talked about in the last lesson what's called the common log, where it has an invisible base 10. If it's just log, you can just use the log button on your calculator, type in what's there, and that's great. If you have any other base with log, there's a special way that you have to type this in. It's using what's called the change of base formula. The way that you're going to enter this in is you are going to first turn this into a fraction. So I'm going to go ahead and use my fraction buttons here. So you can type this in using your fraction button. When we do this, we are going to start with log x. So I'm going to go ahead and type that in. Over log of whatever base is given. So the base, when you write this fraction out, the base with the log always goes on the bottom. The other value goes on the top. Always in that order. Okay? So you can see how I've paired it up. Log x over log 3. It means the same thing as log base 3 of x. This will just allow you to go ahead and graph it. So type it in that way, or you can use your division button and it'll all work the same. It'll just look a little different. So we go ahead and graph. So we can see the picture of the graph. What happens is, again, it's pretty similar to what we see from the original example. The biggest thing, honestly, is that what happens is because the numbers get so tight towards the y-axis here that the calculator can't graph them because they're so close to it. This graph does trail down towards negative infinity. It's just that you can't see it on the graph. So we're going to go plot it ourselves here. We're just going to pull it up to our table. So we're going to see some errors, which means there's an asymptote involved. and that's going to affect our domains. So, same deal as always. We want to pull a handful of numbers that actually fit. So this is where we're going to go ahead here and pull up our table. So I'm going to go ahead and write out our normal XY table. So I'm only going to pull about 3 or 4 of these here just so I can get a semi-accurate sketch. So I don't want to start at 0 because 0 is an error. That doesn't make any sense. Let's start at 1. So 1, 2, 3, 4. So we have 1, 0, 2, 0.631, 3 is 1, 4 is 1.262. You might be wondering why, again, it's going to be really hard to show to 3 decimal places on the graph. Why have all those numbers out? It's just more for consistency's sake. When we're doing computation with logarithms, we're going to get in the habit of going 3 decimal places if need be. So I'm going to go ahead and plot this. So I have 1, 0, 2, 0.63, 3, 1, and 4, 1.262. Now, the error was at 0. So when x is 0, y was an error. So we're going to go ahead and put our asymptote there. And we have our graph. So when this happens, so we have our graph, okay? If I'm going to identify domain and range, so I'm going to erase my table here. So if you need that again, rewind a couple seconds and get that. So my domains will be affected. So if you remember back to the exponential functions, our domains went from negative to positive infinity, but the ranges got cut off. Because logs are inverses, that means the domains are going to be the ones that get cut off somewhere, and the ranges go from negative to positive infinity. So it has kind of like an opposite, an inverse effect, if you will. So our domain is going to, again, just past 0, all the way to positive infinity because it points to the right. Our range, it points down with no stopping to negative infinity, and slowly but surely it is pointing up to positive infinity. So that'll be our domain and range. So, similar to what we did with the exponents. Again, major difference will be vertical asymptote versus a horizontal in this case, and our domains will be the ones that get cut off at a certain point on our graph instead of the range like we saw with the exponents. So you can kind of compare those 2 lessons there back to back if you're looking to see more like how of what the relationship is, but ultimately those are the biggest differences that you're going to see. So that's the first one. Let's take a look here at 1b. And let's go ahead and punch that in. So I'm going to go back to my calculator. Let's see. We have y equals log base 1/2 of x. So once again, the base of the log goes in the bottom of the fraction. Just for ease, I'm going to type this in as 0.5 rather than 1/2 because it means the same thing, and it's just a couple less buttons for me to click around. So log base x over log 1/2, that means the same thing as log base 1/2 of x. We're going to hit graph. So now you see here, because my base was between 0 and 1, it's going to look a lot more like the second graph from up top in the example box, where it kind of flips upside down. So again, same deal. The calculator can only compute so many numbers, which is kind of why it looks like it gets cut off, but it does extend all the way upward. So let's go ahead to our table of values. So same deal. We'll go ahead and pull off a handful of these. So we'll make our XY table. So it looks like 1, 2, 3, 4. So we have 1, 0, 2, negative 1, 3, negative 1.585, and 4, negative 2. So some nicer numbers here. So again, even though our picture kind of gets screwed up on the graphing calculator, this does extend upward towards the y-axis. Once again, our y-axis is going to serve as the asymptote. So there we have our graph. And again, we can identify domain and range. So again, the domain is what's going to be the one that gets cut off somewhere. So again, it's what's going to break the logarithmic function. So we can see in our table 0 is what breaks it. So that means everything just after it's going to be fine, all the way to infinity. And our range for that, once again, the range does not stop. It'll extend downward and upward from negative infinity to positive infinity. So there's your graph there for 1b. Again, same idea, how to enter it, how to identify your domain and range. Now we're going to take a look here at the last example, which again is the exact same idea, but there are a couple more pieces to the equation. So we just really want to make sure that you're typing this thing right so you get the most accurate graph. So let's go ahead and look at the last example. So we have log base 2 of x plus 3 plus 1. So I am going to focus on first the log base 2 of x plus 3 part. So again, the base of the log always goes in the bottom. So again, notice I'm just kind of keeping the same template. If you're going to do that, that's totally fine. Just make sure, again, you're typing everything in the way that it's supposed to before you go ahead and just press enter. So again, log with 2 should be at the bottom because, again, the 2 is your base. The top should have the x plus 3. Now you'll notice there's this plus 1 that's after it. Well, do the same thing on your function. Go outside the fraction and put a plus 1. And it'll compute it the same way. So again, that's what your calculator should look like. That's what you should type in. And that'll match the function that's given to you. So let's go ahead and take a look at the graph. So again, with a base that's greater than 1, you can see it looks a lot like the first example from the top box there. But you'll notice that it's shifted. So the reason why it shifts over a little bit to the left is because of that x plus 3. That means there's a few more x values that can be included that won't break the logarithmic function, and we'll see that from the table here in a second. Same thing though as the other examples. This does technically extend downward. It's just that the calculator cannot compute it. Let's go ahead and look at our table. So you notice at the top here, I'll scroll up a little bit, negative 3 is the first value that breaks. So if I plug a negative 3 into this log function, I cannot get an answer out of it. But everything after it seems to be okay. So again, basically that part of the log function is what's going to determine what works, what doesn't. So we're going to go ahead and do the same thing now that we have our table. Let's go ahead and pull a handful of values. So we'll go negative 2, negative 1, 0, and 1. Negative 2, comma 1. Negative 1, comma 2. 0, 2.585. And 1, 3. Go ahead and plot those. And we put in our asymptote. If you want to put that in first, just so your sketch is a little bit more accurate, that's fine. And again, that asymptote will go in the first place where x makes an error. So negative 3 is where you first see the error. You can go ahead and put your asymptote in there. So once again, we cap that off with our domain and range. So again, our domain, everything just after negative 3 works all the way to infinity. And our range, just like all the other ones, goes from negative to positive infinity. So that's how you graph a logarithmic function. Not much different than stuff that we've already done, and a lot of the same concepts we've looked at in not only this chapter, but in several other chapters, especially with how domains and ranges work. The key is making sure that you punch things in correctly. So again, go back through the video, take a look at how I type things in using the graphing calculator. If you're not getting things that match what my notes say, definitely ask me. There is some practice with this for 8.5. If you want to make sure you're doing things right on a couple of examples, certainly do that. Otherwise, great assignment that goes with this. We'll have a graph or two on it. I am going to throw a couple quote-unquote review questions with it just because the graphing part is so short. But this should be a little bit shorter of an assignment, hopefully, than some of the other ones that you've gotten so far this chapter. So pretty quick lesson. Hopefully this made sense. Again, as always, if you have any questions, shoot me an email, send me a Schoology message. I have office hours on Zoom every weekday. Please get a hold of me. I'll be more than happy to help you out. Again, hope you're doing well. Stay safe, stay healthy, and we'll see you next time.